Welcome back to Search Creators YouTube channel. In this video, we are going to look at the last topic in the cloud computing module 1, which is performance, security, and energy efficiency. In performance, security, and energy efficiency, we are going to look at the performance metrics and scalability analysis. Distributed system performance depends on several factors, including CPU speed, which is MIPS, network bandwidth, which is Mbps, and system throughput, which is TPLOPs and TPS, job response time, and network latency. What it means that the performance of the distributed system based on several factors. These factors are CPU speed, the speed at which CPU works, network bandwidth, system throughput, which is TFLOPS, job response time, and network latency. High performance interconnection networks require low latency and high bandwidth. Like high performance interconnection network require low latency and higher bandwidth. Other key metrics include OS boot time, compile time, input output data rate, system availability, dependability, and security resilience. Like other key metrics include operating system boot time, compiler time, info output, input output data rate, input output data rate, system availability, dependability, and security resilience. Next, we are going to look at dimensions of scalability. Size scalability. In size scalability, increasing the number of processors, memory, or input output channel to improve the performance. Next is software scalability. Upgrading the operating system, compilers, and application software to work efficiently in large system. Like it involves upgrading of OS compilers and application software to work efficiently in large systems. Application scalability, adjusting problem size to match machine scalability. Application scalability in the sense adjusting the problem size to match the machine scalability. Next is technology scalability, adapting to hardware and networking advancements while ensuring compatibility with existing systems. Technology scalability means adapting to the hardware and network advancements which are going to take place. While adapting to them, ensuring compatibility with existing systems. While adapting to the advancements, it also makes sure that compatibility exists with the existing system. Next is scalability versus operating system image count. Scalability is a effect. Scalability is affected by operating system image count. SMP systems have a single OS image limiting scalability, whereas NUMA clusters and cloud environments support multiple OS images, enabling higher scalability. Scalability is affected by OS image count. SMP systems have a single OS image limiting the scalability, whereas NUMA clusters like compared to SMP systems, where the clusters and cloud environment support multiple operating system images, enabling higher scalability. Like they support higher scalability. Like this is a diagram. This diagram represents system scalability versus multiplicity of OS images based on 2010 technology. Like it represents the system scalability versus the multiplicity of OS images based on the 2010 technology. You can go to this diagram. Next is performance models. Amdahl's and Gustafson's laws. Amdahl's law states that system speed up is limited by the sequential portion of a program. Even with infinite processors, speed up is constrained by non-parallelizable code. What this law states that the system speed up is limited by sequential portion of a program. even with infinite processors. Even if you provide infinite processor, speed up is constrained by non-parallelizable code. Like by non-parallelizable code, speed up is constrained. Even if we provide infinite processor also, speed up is constrained by non-parallelizable code. Like here is some representation of Amdahl's law, like speed up equal to S equal to, like this is a formula for Amdahl's, it is an example. Okay. To solve this problem, consider the execution of a given program on a unit processor. Works like this is a problem statement is given. All system or communication overhead is ignored here. Reverse time or exception handling time is also not included in the following speed up analysis. Amdahl's law states that the speed up factor of using n processor, like infinite processor system over the use of single processor, is expressed by speed up equal to S equal to, like this is expressed in that manner, like for Amdahl's law. In this, the maximum speed up of n is achieved only if the sequential bottleneck is reduced to zero or the code is fully parallelizable with when the factor is equal to zero, as the cluster becomes sufficiently large. Like this is the complete explanation of Amdahl's law. You can go through this. Next is problem with fixed workload. Like this is another explanation of Amdahl's law. You can go through this. Next is Gustafson's law addresses, like this is the another law. Here we saw two laws, and this is Gustafson. The explanation for Amdahl's law is I have already explained. It is present here. Next is Gustafson's law. In Gustafson's law, address this limitation by scaling the workload along with system size, resulting in better efficiency in large distributed systems. Like Gustav's law addresses this limitation by scaling the workload along with the system size, resulting in better efficiency in large distributed systems. Here you can observe more information about Gustav's law. Next, we are going to look at system availability and fault tolerance. High availability is crucial in clusters, grids, and P2P networks and clouds. It is defined as system availability equal to MTTF by MTTF plus MTTR. In this, MTTF stands for mean time to failure and MTTR stands for mean time to repair. For system availability, MTTF by MTTF plus MTTR. If we do this, we can get the system availability. This is a diagram representation. It shows estimated system availability by system size of common configuration in 2010. Next, we are going to look at fault tolerance strategies. These strategies include redundancy, component reliability, and failover mechanisms. As system size increases, availability decreases due to higher failure probability. Grid and cluster have better fault isolation than SMP and MPP systems, while P2P networks have the lowest availability. Like fault tolerance include redundancy and component reliability and failover mechanisms. And as system size increases, availability decreases due to higher failure probability. Grids and clusters have better fault isolation than SMP and MPP systems. SMP means symmetric multiprocessing and MPP means massive parallel processing, while P2P networks have the lowest availability. Next, we are going to look at security challenges in distributed system. Common threats are information leak, data integrity breaches, denial of services, attacks, and unauthorized access. Information leak means loss of confidentiality, like leaking of private details. Data integrity means breaches means user alternations are done without permission. Denial of services attacks like DOS, disrupting system operation. Unauthorized access means exploiting open computing resources. Like the authorized person is not accessing, like the different person who is not used has accessed, and exploiting of open computing resources has been done. Like these are the common threats. Security responsibility in cloud models. Next, we are going to look at security responsibilities in cloud models. Like this is a diagram representation. It shows various system attacks and network threats to cyberspace, resulting four type of losses. Here you can see four type of losses: loss of confidentiality, loss of integrity, loss of availability, and improper authentication. You can go through this diagram. SaaS, which is software as a service, provider handles all security. Like in software as a service, provider handles the security. PASS, like platform as a service. PASS, platform as a service, like provider ensures data integrity and availability, but user manages the confidentiality. Next is infrastructure as a service. Users handle most security function while provider ensures availability. Copyright protection in P2P networks. Collusive privacy. Paid client share copyrighted content with unpaid clients like pirates, affecting commercial content delivery. Again, buy the same document from you by paying money. By this, the commercial content delivery will be affected. Next is content poisoning scheme. Proactively detects and prevents piracy using identity based signatures and time-stamped tokens, protecting legitimate clients while stopping colluders and pirates. Content poisoning scheme, what it does is that it protects the legitimate clients by by giving piracy using, like giving identity based signatures and timestamp tokens, protecting legitimate clients while stopping the colluders and pirates. Next is reputation system, essential in detecting and addressing piracy in P2P networks and digital content sharing. Reputation system means essential. It is essential in detecting and addressing piracy in P2P networks and digital content sharing. Next is system defense technology. First generation tools focused on preventing intrusions through access control policies, cryptography, and tokens. Next is second generation tools for detecting intrusions. Example: firewalls, IDS, reputation systems, and triggered remedial actions. Next is third generation intelligence system that responds to intrusion and adapt to security threats. Next is data protection infrastructure. In that security infrastructure, it involves trust negotiation, reputation aggregation, and intrusion detection against viruses and DDoS attacks. Security infrastructure means it involves trust negotiation, reputation aggregation, and intrusion detection against viruses and DDoS attacks. Next is cloud security. Cloud service models are IAS, LASS, IASS, PASS, SASS. It divides security responsibilities. In that, infrastructure as a service, users manage confidentiality, providers manage data integrity and availability. Platform as a service and software as a service, both providers and users share responsibility for data integrity and confidentiality. Next is piracy prevention. Measures against online piracy, copyright violation in digital content, that is piracy prevention. Next is energy efficiency in distributed computing. Energy consumption challenges. System face rising energy costs, especially in large scale data centers and HPC systems. Example Earth Simulator and Petaflop. Next is unused servers. Many servers in data centers are left powered on without use, leading to significant energy waste. For example, 4.7 million idle servers are powered on and left without use globally. Next is potential savings. Estimated saving of 3.8 billion in energy costs and 24.7 billion in operational cost from turning off unused servers. This is the diagram representation of four operation layer of distributed computing system, which are application layer, middleware layer, resource layer, and network layer. Next, energy in active servers. Techniques needed to reduce energy consumption without affecting performance. Like new techniques need to be evolved to reduce energy consumption without affecting the performance of the computer systems. Next is energy management in distributed systems. Four layers are there: application layer, middleware layer, and resource layer. First, we are going to look at application layer. It focuses on energy aware applications that balance energy consumption with performance. Next is key factors. Instruction count and storage transaction affect energy use. Like instruction count and storage transaction affect the energy usage. Middleware layer. It manages energy efficient scheduling and task management, incorporates energy aware techniques to optimize power usage during task scheduling. Next is resource layer. Manages hardware, example CPU and operating system to optimize energy usage. Dynamic power management, which is DPM, switches between idle and low power state. Next is dynamic voltage frequency scaling, which is DVFM, controls power consumption by adjusting voltage and frequency. Next is network layer. In network layer, it focuses on energy efficient network routing and protocols. New energy efficient routing algorithms and models are needed for optimized performance and reduced energy consumption. Next is energy efficiency techniques. The DVFM method enables exploitation of slack time, which is idle time, typically incurred by inter-task relationship. Like explanation on DVFS, which is dynamic voltage frequency, is given here. These are some equation in DVFM, and here is an example of how DVFM works. This figure shows the DVFM technique saves energy compared to traditional practices by reducing the frequency of voltage and or during voltage during slack time. So this is all about module 1 in cloud computing, which is distributed system models and enabling technologies. This video marks the end of the module 1 in cloud computing. I hope you have downloaded the module 1 notes from our website. If not, you can download the notes from our website link, which is mentioned in the below description box. Stay tuned for upcoming videos on remaining modules of cloud computing. Thanks for watching the video. Please like, share and subscribe to our channel.